is Muhammad Al-Surifi bin Rajab.
My name is Muhammad Aidin bin Muhammad.
My name is Muhammad Al-Amin bin Hamzah, and my name is Wong Zhengya.
My name is Dahitan.
So our objective of this project is to design a material handling system using an actuating system and sensor by using PLC controller
And to verify output devices by using input devices with instruction and diagram using CX controller. I will explain about our design of the box. Okay, as you can see here, we make it into the two parts. First one is upper part, the second one is bottom part. Okay, for the upper part, we make it a hole to that a ping pong ball can go through it. And the second one is for the metal plate, we make it higher from the cap to make sure it is easier to sense by the metal sensor. And for the bottom part, at the front view, you can see here we make it transparent so that we can see what happened inside this box. That's all for me. Thank you.
As you can see, this is a diagram of our PLC system. On the left side, these are our input devices, which include the right proximity sensor, left proximity sensor, magnetic sensor, black switch, and red switch. While for the output devices on the right side, which include left relay, right relay, bottom right piston, top right piston, bottom left piston, and top left piston. And in the middle of the diagram, this is our PLC controller, and one terminal of input devices are connected to the input terminal of the PLC as shown, while one of the terminal output devices are connected to the output terminal of the PLC as shown. We also can see that the positive terminal of the NPN proximity sensor and the COM terminal of the PLC is connected to the positive terminal of the PLC. This made the terminal of the input and output devices connected to the COM terminal become positive. And lastly, the rest of the input and output terminal that haven't been connected are connected to the negative terminal of the PLC in order to complete the whole circuit.
The operation of the PLC starts with the moving of the conveyor belt from right to left. The box is initially put at the right and start moving as the red switch is turned on. When the right sensor detects the box, it gives input to the PLC and result in the extension and retraction of the pistons on the right side as shown. As you can see from the movement of piston just now, the top right piston and bottom right piston extend and retract in a way to release two ping pong balls into the box. As the operation finish, the box continue to move to the left as the conveyor belt starts moving. When the box is detected by the left sensor, the belt stops moving and the pistons on the left side act in the same way as the right pistons to release two ping pong balls into the box. As the ping pong balls have been released into the box, the belt starts moving again, but this time it moves to the right side to get the rest of the balls. the sequence of the operation is looped back again, which the box will be detected on the right sensor to receive the balls. Then it will finally moves to the left side again for the last operation. As you can see, after 8 ping pong balls have been released into the box, the wall operations stop. This is because we use the magnetic sensor connected to the top left cylinder piston as sensor in order to determine termination process. To get more details about the whole operation, let us move on to the next session. Basically, our ladder diagram is done according to the sequence that will determine our output. And there are 10 sequences for our system to run, which are, Sequence 1, Moving of Belt. Sequence 2 and 4, Top Right Cylinder Extend. Sequence 3 and 5, Bottom Right Cylinder Retract. Sequence 6 and 8, Top Left Cylinder Extend. Sequence 7 and 9, Bottom Left Cylinder Retract. And lastly, Sequence 10, Reverse the direction of belt movement and termination. The sequences are represented as relay, as shown above, which are 200.01 to 200.10. Each relay is connected to respective output that will turn the component on or off. Next, the timer and counter is included in our ladder diagram to allow us to have better control on the output. Then, the relay, timer and counter are arranged so that the PLC will function according to the program. First, when the red switch is turned on, the sequence 1 is turned on also. Since the sequence 1 is connected to the relay A as input, the relay A is turned on and the belt starts moving to left.
When the right sensor detect the box, relay 200.02 is turned on and the timer start counting. In this case, the sequence 1 is turned off and belt stop moving as the normally closed switch of 200.02 is turned on. In this case we can see that when there are input for the piston cylinder, the relay will not turn on to ensure the box can receive the ping pong balls on the spot. The sequence 2 will trigger top right cylinder to extend.
This ensures that the 3 other ping pong balls is hold and prevent them to fall altogether into the box. As the timer is still counting, timer 1, 2 and 3 will play important role to ensure the first ping pong ball is released smoothly. When timer 1 activated, it turns on the sequence 3, which will give input to the bottom right piston to retract. This allows the ping pong ball to drop into the box. Then when timer 2 is activated, it turns off the sequence 3 again and this makes the cylinder retract. Note that there is only 1 second interval for the extension and retraction for the bottom right cylinder. Note that when the timer 3 is turned on, sequence 2 is turned off and the sequence 4 is turned on simultaneously. This is to make sure the sequence 1 is still off to avoid the belt from moving. In order to allow the second ball to drop down, we delay the input of sequence 4 by 1 second by using the timer 7. Which means the top right piston will retract for 1 second before it is turned on to extend again. So, in the 4th second, the top right piston and bottom right piston extend and retract respectively. This is because sequence 5 is turned on as the timer 4 is turned on at the 4th second. This is the time where the bottom right piston to retract and release the second ping pong ball into the box. Further onwards on the 5th second, the normally closed timer 5 is turned on and this makes the sequence 5 to turn off, which means the bottom cylinder extend again to prevent other balls to fall into the box. Lastly, at the 6th second, the normally closed timer 6 turns on and it makes the sequence 4 turn off. At this moment, the sequence 1 turn on as the other sequences are all off. This allows the box to move to the left to fetch the rest of the ping pong balls. Now, let us look back what actually happened at the right side. While the box reach the left sensor, the belt stop and the timer start counting again as they are reset when they lost the input from the right sensor. The left sensor also turn on sequence 6 which extend the top left piston. For the first second, the timer 1 turn on and this turn on the sequence 7 which make the bottom left piston retract. This allow the third ping pong ball to be released. Then on the next second, the normally closed timer 2 turned on and this turn off the sequence 7 and make the bottom right piston extend.
On the third second, timer 3 is turned on and this turn off sequence 6, to be off and sequence 8, to be on at the same time. The reason is same as before, which we need to avoid the sequence 1 from turned on before the fourth ball is being dropped down.
While for the 4th second, the timer 4 and timer 7 is activated and this turn on both sequence 9. Also, the top left and bottom left piston is being turned on at that moment. We can also notice that the sequence 9 also turn the sequence 10 on, which is responsible for the activation of relay B for changing the direction of belt movement. Further on to 5th second, the normally closed timer 5 is turned on and this turn the sequence 9 off, which also allow the bottom right piston to extend. From this moment also, we can notice that the sequence 10 still activated as the latching connection hold the sequence on. Lastly, on the 6th second, the normally closed timer 6 is turned on and this close the sequence 8, which make the top left piston to retract. Now, since all sequences, expect sequence 10 is turned on, the sequence 1 turn on again, but this time it moved to the right side because the relay B is turned on by the sequence 10. Now, let us see how this happens on the left side. As the box is moving to the right, the whole operation will loop back to sequence 2 when it is detected by right sensor. The operation will stop when 8 ping pong balls is released. Now, in order to terminate the whole operation, we use magnetic sensor, that is fixed on the top left piston as the input for the sequence 1. The magnetic sensor will give input each time the top left sensor moves, which means that after the top left piston moves 4 times, it is confirmed that the 8 ping pong balls have been released into the box. Then, the counter 1 will turn on, and this normally closed counter will stop the sequences, and result in termination of all operation.